In this lecture, I'm going to discuss problems on double integrals. So we'll take a first problem. Evaluate integral over region R f of x comma y into dA, where f of x comma y is equal to 1 minus 6 into x square y, and the region R contains where x lies between 0 to 2 and y lies between minus 1 to plus 1. So let us move to the solution of the problem. So we have integral over R f of x comma y into dA, where f of x comma y is equal to 1 minus 6 into x square y. So region of integration is here region is x lies between, so 0 less than equal to x less than equal to 2, and y lies between minus 1 to plus 1. So let us draw the region of integration. So when x is equal to 0, x equal to 0 is the y-axis, x equal to, which is parallel to the y-axis, this is x equal to 2, and y is equal to 1 is parallel to the x-axis, this is y is equal to 1, and this is y is equal to minus 1. So the region of integration is, so when x is equal to 0 to 2 and y is equal to 1 to minus 1, so this is region of integration. So here we can observe that region R as a definite shape, which is a rectangle. So therefore dA can be written as, so dA can be written as either dx into dy, or we can write dy into dx. It means that limits of integrations are constant limits. So that is x varies from 0 to 2 and y varies from minus 1 to plus 1. Therefore, the order of integration is not a matter. It means that we can integrate with respect to x first, then y, or we can integrate with respect to y, then x. So therefore we can write integral over the region R f of x comma y is 1 minus 6 x square y into dA can be written as, so integration from y varies from minus 1 to plus 1, x varies from 0 to 2, the function 1 minus 6x square y into, let me write dA can be written as dx into dy. So let us integrate with respect to x, keeping y as a constant. So that is integration from y is equal to minus 1 to plus 1. So integration of 1 with respect to x, that is x minus 6y is constant, x square integration, that is x cube by 3. So limits of integration x is equal to 0 to 2, then into dy, let us write. So let us apply the upper limit. So integration from y is equal to minus 1 to plus 1. Apply the upper limit x equal to 2, that is 2 minus that is 3 2s are 2 into y, x is equal to 2, that is 2 cube, minus of then you take x equal to 0 as a lower limit. So in x is 0 0 minus in x is 0, that is 0 into dy. This is equal to integration from y is equal to minus 1 to plus 1. So 2 minus 2 cube 8 to 2 is 16, 16y into dy. Now let us integrate with respect to y. So integration of 2 with respect to y is 2y minus 16 y square by 2. Limits are minus 1 to plus 1. So let us apply the upper limit 1. So 2 into 1 minus 2 is 16, 8 times of 1 square. Then let us apply the lower limit y is equal to minus 1. 2 into minus 1 minus 8 times of minus 1 whole square. Let us simplify this. So 2 into 1, 2 minus 8 into 1 square, that is minus 8, minus of minus into minus plus 2, that is this minus n here. So minus into minus plus 8 times. So that is equal to minus 8 plus 8 get cancel. So 2 plus 2, that is 4. So therefore interval over the region R, where R is the rectangle. So the function f of x comma y is 1 minus 6x square y into dx dy, that is equal to 4. Since the limits of integrations are constant, so integration over the region R 1 minus 6x square y into dA also can be written as, so integration from x equal to 0 to 2, y is equal to minus 1 to plus 1, 1 minus 6x square y into dy dx. dA is written as dy into dx in this form. So here you have to integrate with respect to y first, then with respect to x. So let me integrate with respect to y by treating x as a constant. So this is equal to integration from x is equal to 0 to 2. So integration of 1, that is with respect to y minus 6 into x square is constant, integration of y, that is y square by 2. Limits of integration of y is minus 1 to plus 1 into dx we can write. So this is equal to, let us apply the upper limit 1, x is equal to integration from x equal to 0 to 2. Let us apply the y is equal to 1, 1 minus 2 3 is 6, 3 times of x square into 1 square minus of, let us apply the lower limit minus 1, minus 1 minus 3 times of x square into minus 1 whole square into dx we can write. This is equal to integration from x is equal to 0 to 2. So 1 minus 3x square minus into minus plus 1 plus 1 minus into minus plus, so 3x square minus 1 whole square is plus 1 into dx. So this is equal to integration from x equal to 0 to 2, 1 plus 1 2 minus 3x square plus 3x square get cancelled into dx. And integrating with respect to x, integration of 2 with respect to x is that is 2x, limits are 0 to 2. Let us apply the upper limit in x equal to 2. So 2 times of n x is 2, that is 2, then let us apply the lower limit 0 minus 0, that is equal to 4. For interval over the region R 1 minus 6x square y into dA, so that integration from y is equal to minus 1 to plus 1, then x is equal to 0 to 2, 1 minus 6x square y into dx dy is same as integration from x is equal to 0 to 2 and y is equal to minus 1 to plus 1, 1 minus 6x square y into dy dx. It is equal to 4. You observe that, so when the limits of integrations are constant, so the order of integration is not a matter. So either you can integrate with respect to x first or then y, or integrate with respect to y first then x. Consider the second problem. Sketch the region and evaluate integration from 0 to 3 and 0 to 2, 4 minus y square dy dx. Here dA is equal to dy into dx we have taken. So anyway, so limits of integrations are constant. So dA can be written as either dy into dx or dx into dy. In the problem we have dA is written as dy into dx. Therefore, so y varies from 0 to 2 and x equal to 0 to 3. The region R is bounded by x varies from 0 to 3. So 0 less than or equal to x less than or equal to 3, and y varies from 0 to 2. So that is 0 less than or equal to y less than or equal to 2. Draw the region. So let us consider the coordinate system, x-axis and y-axis. X is equal to varies from 0 to 3. X is equal to 0, that is y-axis, and draw the line x equal to 3, which is parallel to the y-axis, and y is equal to 0 is the x-axis, and let us draw the y is equal to 2, which is parallel to the x-axis. So this is the region of integration. So the region R is bounded by the line x equal to 0 and 3, and y is equal to 0 and 2. Integrate this function with respect to y, then x. We have integration from x is equal to 0 to 2, 3, and y is equal to 0 to 2, 4 minus y square into dy dx. First you have to integrate with respect to y, then integrating with respect to x later. So this is equal to integration from x is equal to 0 to 3, integrate with respect to y keeping x as a constant. So integration of 4 with respect to y is 4y minus integration of y square is y cube by 3. So limits are 0 to 2 into dx. So this is equal to integration from x is equal to 0 to 3. Let us apply the upper limit. Whenever y you take upper limit to 4 into 2 is 8 minus when y is 2, that's 2 cube 8 by 3 minus then let us take y is 0 lower limit, that is equal to 0 into dx. So 8 minus 8 by 3 is a constant. Take LCM and take it outside, that is 8 3 is 24 minus 8 16 by 3. Integration from x is equal to 0 to 3, 1 into dx, that is equal to 16 by 3 integration of 1 with respect to x, that is x. Limits are 0 to 3. So 16 by 3 into, let us apply the upper limit x equal to 3 minus, let us apply the lower limit 0, that is 0. So 16 is the solution. Get the region and evaluate integration from 0 to pi and 0 to x, x into sin y dy dx. So we'll move to solution. We have integration from 0 to pi, 0 to x, x into sin y into dy dx. So in this case order of integration is with respect to y first, then should move to with respect to x here. So therefore, so y varies from 0 to x and x is equal to 0 to pi. When r is bounded by the limits, x varies from 0 to pi and y varies from 0 to x. So you can observe that x limits are constant limits and y limits are the variable limits. First you have to integrate with respect to y, then with respect to x. Therefore dA can be written as, that is dy into dx. Okay, let us plot the region. Consider the coordinate system. Horizontal line is x-axis, vertical line is y-axis. So x varies from 0 to pi. So when x is 0, that is y-axis, x equal to pi is a constant which is parallel to the y-axis. So this is x is equal to pi. So y is equal to 0, which is the x-axis, and y is equal to x. Y is equal to x is a straight line passing through the origin. This y is equal to x is a line passing through the origin. So region of integration R is bounded by the line y is equal to x, y is equal to 0, and x equal to pi. So at this point x equal to 0. So you have to integrate with respect to y first, then with respect to x. Let us consider the vertical steps. So now integration from x equal to 0 to pi and y is equal to 0 to x into sin y dy into dx.
Y limits are variable limits. So first you have to integrate with respect to y, then you should move to respect to x. So let us integrate with respect to y, keeping x as a constant. That is equal to x is equal to 0 to pi. So x into sin y integration minus cos y. So limits of y are 0 to x into dx. So this is equal to integration from 0 to pi x into, let us apply the upper limit y is equal to x. So let us take minus sign outside, that is cos x minus, when cos 0 is, when y is equal to 0, then cos 0 is 1 into dx. So this is equal to minus of integration from 0 to pi x into cos x minus x into dx. Now let us integrate with respect to x. So that is minus sin of, where we have product of two functions. Let us apply the integration by parts, where x is first function and cos x is second function. That is integrating term. X into cos x integration sin x minus x differentiation 1 into integration of this, that is minus cos x minus x integration, that is x square, but limits are 0 to pi. So that is minus sin of, let us apply the upper limit when x is equal to pi, pi into sin pi. So minus into minus plus cos pi minus pi square by 2 minus of, then let us apply the lower limit 0. So sin 0 0 minus into minus plus cos 0 is 1 minus, when x is 0, that is 0. So this is equal to minus of, so pi into sin pi, that is 0, this is 0, sin pi is 0, and cos pi is minus 1 minus pi square by 2, that is minus into plus minus 1. So that is equal to minus of minus 1 minus 1 minus 2 minus is pi square by 2, pi square by 2. So take minus n inside, so minus into minus plus 2 plus pi square by 2. So this is solution.
Consider next problem. Sketch the region of the integration and evaluate integration from 1 to log 8 and 0 to log y e power x plus y to dx dy. So we'll move to solution. We have integration from 1 to log 8 and 0 to log y e power x plus y into dx dy. So here order of integration is first you have to integrate with respect to x, then you should move with respect to y. Therefore x limits are 0 to log y and y limits are 1 to log 8. Therefore the region of integration R is bounded by, so x limits are 0 less than or equal to x less than or equal to log y, and y limits are 1 to 8, that is 1 less than or equal to y less than or equal to log 8. Observe that y limits are constant limits, so where x limits are variable limits because x is a function of y, that is log y. So therefore you have to integrate with respect to x first, then with respect to y. So let us sketch the region R. So consider the coordinate system x-axis and y-axis. So when y is equal to 1, so this is y is equal to 0 x-axis. So y is equal to 1 is a line parallel to x-axis, and y is equal to log 8, so which is parallel to the again x-axis. Let us take y is equal to log 8, and x varies from 0, x equal to 0 is the y-axis, and x equal to log y. So log y checked with the line y is equal to 1. So at this point 0 comma 1 is a curve. So this is x equal to log y. So log y intersect with y is equal to 1 at this point. This is 0 comma 1. So therefore region of integration is bounded by the y is equal to 1 and y is equal to log 8 and x equal to 0 and x equal to log y. So let us consider the horizontal strip because x limits are the variable limits x equal to 0 to log y. We have integration from y is equal to 1 to log 8 and x equal to 0 to log y. E power x plus y can be written as e power x into e power y dx into dy. Since x limits are variable limits, first you have to integrate with respect to x, then we move with respect to y. So that is equal to integration from y is equal to 1 to log 8. So integrate e power x with respect to x, treating y is constant. So e power y into e power x integration e power x. Let us apply the limits 0 to log y into dy. So this is equal to integration from y is equal to 1 to log 8 e power y into, so when x is equal to log y, e power log y minus when x is equal to 0 e power 0 into dy. So this is equal to integration from y is equal to 1 to log 8 e power y into e power log y can be written as y minus e power 0 is 1 into dy. Since e power log y is equal to y and e power 0 is equal to 1. So this is equal to integration from y is equal to 1 to log 8 y into e power y minus e power y into dy. So now we integrate with respect to y. Here we have product of two function. By applying by parts we can integrate it. That is y into e power y integration e power y minus y differentiation 1 into e power y minus e power y integration e power y limits 1 to log 8. So now let us apply the upper limit wherever y is equal to log 8. Log 8 into e to the power of log 8 minus this 2 times of e to the power of log 8 minus of when y is equal to 1 1 into e power 1 minus 2 times of e power 1. So this is equal to log 8 into e power log 8 is 8 here minus 2 times of 8 e power log 8 is 8 minus e power 1 since minus 2 times of e power 1 plus e power 1 is minus e power 1, so minus of minus plus e power 1 this is. So this is equal to 8 times of log 8 minus 8 to the 16 plus e.